This video will focus on solving absolute value equations. So before we tackle absolute value equations, let's review what absolute value is in general. The absolute value of a number is its distance from 0 on a number line. So absolute value represents distance from 0. Since it represents a distance, it will always be positive. Because if you think about it, you can't have a negative distance. You would never say you ran -3 miles. You would never say that something was -4 inches tall. Distance is always positive, which is why the absolute value function always produces 0 or a positive number, because it's talking about distance from 0. The absolute value function also uses the straight up vertical lines. So when you see a number inside of those straight up vertical lines, that means that you're finding the absolute value of whatever is between those two vertical lines. So the 4 examples you see below, the first example says the absolute value of 5. Well, 5 is 5 units from 0, so the answer is 5. The absolute value in letter B of -3, yes, it's -3, so it moved in the negative direction, but it is 3 units away from 0. So it's positive. Remember, it will always be a positive number. It is distance from 0. Letter C, we have the absolute value of -28. That is 28 units from 0, so it's a positive 28. And then in D, the absolute value of 4.5. It is 4.5 units from 0, so the answer is a positive 4.5. Notice every single one of these answers is positive, because anything coming out of these absolute value brackets will be a positive value once the absolute value is evaluated. So that's something we have to keep in the back of our mind. Absolute value is distance from 0. So now that we've looked at absolute value, let's think about this in reverse. Here I'm giving you an equation and it says the absolute value of x is equal to 3. Remember, absolute value is meaning distance. So whatever value is in here has to have a distance from 0 of 3. And hopefully already at this point you're thinking, oh, well duh, x would be equal to 3. And yes, that is one of the answers. But something you have to think about is absolute value is distance from 0. And while yes, 3 is a number that has a distance from 0 of 3, there's actually a second number that is also 3 units from 0. And if we were to place it inside of those absolute value brackets, you would also get an absolute value or distance from 0 of 3. And that's x equals -3. So where absolute value equations get tricky is you have to think outside the box. You have to think, okay, yes, absolute value finds distance from 0, and yes, it only will produce positive numbers. But if you're finding the value for x that makes that equation true, you have to think through all possible values that could have a distance from 0 that is equal to, in this case, 3. And here we would actually have two answers. You could say, well, x could be 3 or x could be -3. And this idea is the foundation that we're going to need to understand as we move forward and solve absolute value equations. So here are a couple more examples, and hopefully you've now already picked up on this, but the absolute value of x is equal to 7, you would have two answers. You would have x is equal to 7 or x is equal to -7. There's two possible values with a distance from 0 of 7. The second example here, absolute value of x equals 3.5. You could have x equals 3.5 or x is equal to a -3.5. So again, catching that there are two answers that have a distance from 0 of a positive 3.5 or a positive 7. This third example here, hopefully you didn't rush too fast through it, this is saying the absolute value for x, or the distance from 0, is -12 units. And remember, absolute value will only produce positive numbers on the other side of the equal sign. It will always have a positive distance. So this is saying what number is -12 units from 0, which absolute value is a distance and it must always be positive, so that's not possible. That's a question that actually results in no solution. So not only are absolute value questions tricky because they will possibly have two answers, like in number 1 and number 2, we also have instances like number 3 where they're saying, well, the distance from 0 equals a negative. That's a situation that's not true. You cannot have a negative distance from 0. And as a result, for the third one, we would write no solution. So now we're actually going to dive in and start looking at how we start solving more complex equations that contain an absolute value. So here you can see a problem in front of you, and it says the absolute value of x minus 3 is equal to 6. And it doesn't look too difficult, but something we have to be careful of is that the absolute value works like prison bars. So say, for example, I had the following problem. Say I had 2 absolute value of x minus 4 is equal to 10. Most of your gut instincts are telling you, oh, you should distribute right into those absolute values. But the thing is, nothing can break in. So you can't distribute in. You can't break into the prison that is the absolute value. You can't distribute inside of it. The other really tricky part about this is, say, for example, I'm going to go back to the problem I have up above. I have this right here. Most of you are saying, oh, well, I could probably just add 3 to each side and get my answer, but you can't break anything out of it. Absolute values you can't distribute in, so you can't break in, and you can't break out. So we have to take some other steps when we're dealing with absolute value in order to ensure that we solve them correctly and for every possible value. So what we're going to do is we're going to follow the following steps on the screen in order to solve this equation right here. So the first thing we're going to do is we're going to solve for the absolute value alone on one side of the equation, which in the problem I gave you, you have x minus 3 inside the absolute value equals 6. This is already done for you. So you have the absolute value all by itself on one side of the equation. Then what you're going to do is this is how we're going to break down the prison walls. We're going to break down the prison walls by thinking through step 2 very carefully. So we're going to set what is inside the absolute value equal to its 2 possible values. So here's where we're going to break down the prison walls. So we have absolute value 1 and absolute value 2. So this inside piece here, when it's evaluated, whatever x minus 3 is, it has to have a distance from 0 of 6 units because the absolute value is going to find its distance from 0. There are 2 numbers that x minus 3 could equal that are a distance from 0 of 6 units. That x minus 3, which breaks down the first prison wall, that inside of that absolute value could equal a positive 6. If the inside of that absolute value equals a positive 6, then it's 6 units from 0. The other option is that x minus 3 could equal negative 6, because if the number inside of that absolute value is negative 6, that also has a distance from 0 of 6. So in order to break down those prison walls, we're going to think through what could this inside piece equal. Well, that x minus 3, when we take its distance from 0, has to have a distance from 0 of 6, which is 6 or negative 6. So we set x minus 3, that inside piece, equal to its 2 possibilities. You then solve each mini equation, and what you'll find is you'll find your 2 values. So here you can see I have many equations, so I have, and I want to keep change this, so I can add 3 to each side and get x is equal to 9. Or if I add 3 here, add 3 here, I find x is equal to negative 3. So notice, not as simple as the problems we saw on the previous slides where it was like 9 and negative 9, 4 and negative 4. But here, as we think through what this middle could equal to break down our prison walls, we find 2 possible values for x that make this equation true. And let's actually check our answers to make sure that these work. So if we try answer 1, we're going to have 9 minus 3 equals 6. Well, 9 minus 3 is 6 there. So from here, if I evaluate the absolute value, 6 is equal to 6. So that first answer works. If I try the second answer, I have negative 3 minus 3. Well, if I use keep change there, I have the absolute value of negative 6, which is in fact 6 and works. So let's walk through a couple more easy examples before we dive into the hard ones. So here what I notice is my first step is always to get the absolute value by itself, which luckily this one already is. Then I want to break down the prison walls. So I have to think through, okay, the absolute value is by itself. What could this inside equal if it needs to be 4 units from 0? So here is where I break down my prison walls. And I say, okay, one option for 2x plus 8 that is 4 units from 0 is that it's 4. And the other option is that 2x plus 8 could be equal to negative 4. 4 and negative 4 are my two possibilities that are 4 units from 0. Then, now that I've broken down my absolute value walls, I solve each mini equation. So I can add a negative 8 to each side. So I have 2x is equal to negative 4, divide by 2, x is equal to negative 2, or, so I have 2x is equal to negative 12, divide by 2, x is equal to negative 6. So here are my two possible answers that if I plug them back in here for x, I will get 4 and negative 4 inside those absolute values for a distance from 0 of 4 units. All right, if I look at this next one, I start off and I notice, okay, I have my absolute value all by itself. So then I'm going to attempt to break down my prison walls, and I realize I need two numbers that have a distance from 0 of negative 9 units. And if I think about absolute value, I know that absolute value will only produce a positive number over here because it's going to be a positive distance. There aren't any numbers with a distance from 0 of negative 9 because negative 9 doesn't make sense for a distance. So if you catch this type of error going on and the problem doesn't make sense because you can't have a negative distance, what you can simply write is that we have no solution because the absolute value function will only produce positive numbers over here, not negatives. So now we're going to tackle a slightly more difficult problem that requires us to use step 1. So those first couple problems we solved had the absolute value alone to start with. This one does not. So if the absolute value is not alone on one side of the equation to start with, you have to solve for the absolute value alone to start. And something to note that we talked about on an earlier slide is that you cannot take anything out of the absolute value or distribute into the absolute value. So this is different than the previous equations you've solved with linear equations. You cannot take anything out and you cannot distribute in. So essentially what we need to do is we need to get this piece all by itself. And the easiest way to do that is to think through, okay, how do I get that part all by itself? Well, I need to start undoing the other items to the other side of the equation. So the first thing I'm going to do is I'm going to undo that negative 4 by adding 4 to each side so that those undo each other. So here I have 2 absolute value, x plus 3 is equal to 16. Then from here, I want to undo that multiplication of 2. The best way to do that, since I can't distribute in, is I'm going to divide both sides by 2. So I end up with absolute value of x plus 3 is equal to 8. So remember, you cannot distribute in and you can't take anything out of that absolute value. Now that it's by itself, I can apply what I did on the previous slide. So I'm going to break down those walls by brainstorming what this inside of this absolute value could equal. That would be 8 units away from 0. So 8 units away from 0 is going to be 8 or negative 8. So I have x plus 3 could equal 8, or x plus 3 could equal negative 8. The inside of that absolute value could be 8 or negative 8. And now from here I can solve my two mini equations. So I have a possibility that x could equal 5, or the possibility that x could equal a negative 11. So final examples here. Remember that our first step when we're solving absolute value equations is to get that absolute value by itself, because you cannot distribute in and you can't break anything out. So you have to get the absolute value alone first. We're going to do that in this first problem by adding negative 6 to each side, so those cancel out. We're left with 3 absolute value, 2x minus or plus a negative 4. I'm going to use keep, change there, equals 30. My next step here is I then need to undo that multiplication of 3 out in front. So we're going to divide by 3 on each side. So we end up with the absolute value of 2x plus negative 4 is equal to 10. So I start by getting that absolute value piece completely by itself. Then I can think through, okay, what does this middle part have to equal in order for that absolute value to have a distance from 0 of 10? And this is how I break down my two walls. I have 2x plus negative 4 could be equal to a positive 10, or 2x plus negative 4 could be equal to a negative 10. Those are my two numbers that are a distance from 0 of 10 units. Then from here I solve each mini equation. So I add 4 to each side. I then have 2x is equal to 14 and 2x is equal to negative 6. Divide each side by 2. And I end up with possibilities that x is equal to 7 or x is equal to negative 3. And then lastly, our final example on the right-hand side, we always start off by getting this absolute value by itself. So we need to divide both sides by a negative 3. Then, once we get our absolute value completely by itself, we then brainstorm what could the middle of that absolute value be. So here then I look, okay, this middle portion of 2x plus negative 5 has to have a distance from 0 of negative 5 units. Well, I know that absolute value can't produce a negative on the other side of the equal sign. It will always be a positive distance. And as a result, I'm going to stop here and note this is a no solution problem. So once I got that absolute value alone, I notice the absolute value equal the negative number. That means that there's no solution to that particular problem. No value of x will be able to make that equation inside of the absolute value produce a negative 5 over here on the right-hand side.